Today, we are looking at the 2025 update from the Google security team. This is not just another Rust is good post. For the first time, memory safety vulnerabilities in Android have fallen below 20% of total bugs. Google is proving that you don't have to choose between moving fast and staying secure. We are going to walk through this blog paragraph by paragraph to see the 1000x reduction they are claiming, because that is huge. Here is the TLDR of the whole report. They found a 1000x reduction in vulnerability density compared to C and C++ code. Here they have mentioned 1000x reduction. But here is the surprise. It's actually faster to ship. Rust code has 4x lower rollback rate and spends 25% less time in code review. In plain English, the safer path is now officially the faster one also. And that's generally don't happen. And Google uses DORA framework, the industry standard for the team performance. You can see here they have mentioned, DORA Metrics. Look at this chart. New Rust code now rivals the volume of new C++. From 2020 to 2025, if you see, the Rust code has been evolved so much. The volume is now, you can say, almost equal. So this allows for a fair comparison. Rust changes need 20% fewer revisions. Here they have mentioned 20% fewer revisions than C++. Why? Because the compiler acts like a pre-reviewer in the case of Rust. It catches the silly mistakes before a human even has to look at the code, saving almost 25% less time usually wasted in review cycles. And that is huge optimization, right? And this is huge for product managers also, because rollbacks are productivity killer. For medium and large changes, Rust rollback rate is 4 times lower than C++. If we see the rollback rate, so you can see the rollback rate Rust changes in Android is 4x lower than C++. You can see from this chart also. For large and medium CLs, the difference is huge. You cannot ignore it. When you submit Rust code, it stays in. This reduces organizational friction. No more emergency postmortems or build respins because of memory leak. Now, Google isn't just topping at the OS level. For kernel also, Android 6.12 Linux kernel now has its first production Rust driver. They have enabled it here. For firmware also, they are pushing Rust into high privilege. This highest risk areas of the phone. And for apps like nearby presence, MLS, and Chromium, that is Chrome, and Google Messages, RCS, secure messaging are moving to Rust. If it is security critical, it's being rewritten. Now Google is being very honest here. They have mentioned about the vulnerability that found in Rust. They almost shipped a Rust buffer overflow in Krabby AVIF. And how they stopped it? Two things. First, sudo harden allocator. This is Android harden allocator used guard pages to turn a potential hack into a noisy crash. And second, they identified a gap in their crash reporting and fixed it. This proves that even unsafe Rust is easier to catch than C++ because it is encapsulated. So you have to focus here what this encapsulated means. If you go and learn about unsafe Rust, then you will know that you have to put that particular code that is unsafe in a block, and that is highlighted. So rather than C++, it is very easy to catch bug in unsafe Rust. That is the whole thing. And let's talk about this 1000x math that they have mentioned in detail. So Google has 5 million lines of code in Rust right now in Android, and they found one potential vulnerability. That's 0.2 per million lines, right? And their historical data for C and C++ shows 1000 vulnerabilities per million lines of code. You can see, but for Rust, it is almost 0.2 vulnerability per 1 million lines of code. For C and C++, it is 1000 memory safety bugs. And that is almost, if we talk about the reduction, then compared to the C++, for Rust, it is more than 1000x reduction. And that's what the math coming from. So the conclusion is, even if you assume unsafe Rust is risky, the empirical evidence shows it is significantly safer. See here that unsafe Rust is significantly safer. Even at the 4% of code unsafe, blocks get more scrutiny and is easier to reason about than C and C++. If we compare it to C and C++, then a unsafe Rust. So the takeaway is clear from this. We used to think security was a cost, something that made us slower. Google has proven that fixing the foundation, you actually move faster. We are moving from move fast and break things to move faster by fixing things at the start only. If you haven't started your Rust journey yet, this data is strongest argument I've ever seen to start today. Because Google is changing everything into Rust, mostly because of the memory vulnerability. And whatever graph you see here is the proof that they are using it and how it is getting increased year by year from 2023 to 2025. This is the rollback rate. And if you see the code volume, then you will see here. Okay, this is revisions. Yeah. No, median review. Yeah, this one. The how much code for Rust and C++ is present. So from 2020 to 2025, it is almost equal now. So what more proof you need than this? So yeah, that's it for today. That's it for this blog, and I'll suggest everyone to go through this blog to understand things in more detail, because this is very good blog to read about, and it's not very long also. I'll put this blog in the description also, so go through it. And yeah, remember, we'll keep it simple.